Today we're discussing angle measure. We have some vocabulary. We have actually several vocabulary today. So our first one is degree. Degree is a unit of measure used when we're measuring things like angles and arcs. Our next one is array. Array is part of a line. It has an endpoint and then extends forever in one direction or indefinitely in one direction. We use the abbreviation over here. Just like a line, we have two letters. And then over the top, instead of having arrows on both ends, since it's only going in one direction, we only put it going to the right. So we start with the letter that is the endpoint. The second letter is some point that is along that line in whatever direction we're going. Next, we have opposite rays. This is two rays that share an endpoint and go in opposite directions forever. We also call this a straight angle. So my picture down here, we have two rays. We have PR, so we started with P, we went in the direction of R. We've got our arrow going just one way. And we have ray PS, we start at P, go on towards S. Those are our opposite rays. Next we have angle. Angle is two non-collinear rays that have a common endpoint. The rays are called sides of the angle, and the common endpoint is the vertex. So I have a picture down here for us. So we have BA, this is one ray, that's a side, and we have BC, that's another ray, that's our other side. And then where they meet, their common endpoint, that is our vertex. When we're naming an angle, we put this angle symbol out in front, and we use three letters. A, B is, the center one is always our vertex, and C. It doesn't make any difference which one of our side pieces we say in what order, as long as our vertex is always the center. So I could have also named this CBA. Next, we have interior and exterior angles. Interior just means that it is inside of our angle, so somewhere in here. A point is in the interior of an angle if it does not lie on the angle, but is inside of it. Okay, so not something that's on it, but actually inside of it. And exterior is when we have something on the outside of our angle. So a point is on the exterior of an angle if it does not lie on the angle itself, but is outside of the angle. I said we had several of these, so let's keep going. Next, we have right angle. So this shouldn't be new to you. A right angle is an angle with measurement of exactly 90 degrees. Has to be exact. Acute is an angle with measurement of less than 90 degrees. Obtuse is an angle with measurements of less than 180 and more than 90. Then we have congruent, angles or segments that have the same measure. They have the exact same measure. And then the last one is bisect. It divides something into two congruent parts. We can bisect a segment, we can bisect an angle. We're just cutting it into two congruent parts. All right, so let's look at some examples then. I have a few pictures on here for you. So our first example, we're looking here at this quadrilateral. We're just going to be naming some things. So we're going to name the vertex of angle 4. So we have to locate angle 4. It's right here. So we're going to name the vertex that goes with that. So if this is angle 4, the common endpoint for our rays is going to be right here at B. Okay, that's where our two lines meet for angle 4. So it's point B. The next one, we're going to name the sides of angle BDC. So we have BDC. So what are my sides? So we have one side here, and remember we start with the common endpoint, so that's D. So we have D, B, and that is a ray. And my other side, D again, because that's my endpoint, and then it goes towards C. And make sure you're putting the symbol over the top. We only have one arrow on these. And then the last one, we're going to write another name for angle DBC. So DBC. What is another name for angle DBC? Now if you remember, I said we can go in the opposite order. So one way I can name this is angle, and then I'm going to go the opposite direction, so CBD. Another way to name it, since I have a number here, is with the number. So DBC, here's my number that goes along with that angle, so I can also call this angle 3. So two different ways to name that angle. Now we're going to classify our angles. So I have this picture over here. And we're going to classify the angles as either right, acute, or obtuse. So that was these up here at the top that we just did. Okay? So classifying our angles, we're looking at angle MPR. So starting at M, following my line to P, and then over here to R. What kind of an angle is MPR? So we're going to start with the first one, right. Is it exactly 90 degrees? Well, no, that's more than 90 degrees. The next one is acute. That was less than 90. We'll know because we said it's more than 90. So this one has to be obtuse. Let's look at the next one, RPN. So we're going to follow this R, P, and then up here to N. So what is this angle? What does this box down here mean? I see this box attached to my angle. Well, that box means that it's a right angle. So we know, even without having to measure, this is a right angle. If they did not have that box, we would have to measure it to know for sure. And then our last one, we've got NPS. N, follow it to P, and then to S. Well, if the bigger one, NPR, was 90, this one is less than that. So it's going to have to be the one that's less than 90, which is acute. Okay? Great job. Let's go on. All right, so we have another picture here. This time we're going to be working with some different information and applying it, some of our vocabulary terms. It says ray QS bisects. Bisect, we said, cuts it into two equal parts, angle PQT. So that means we know that this angle is exactly the same as that one. It cut it into two equal parts. So I'm going to go ahead and label that. We put those symbols in there to say that those are congruent. And then we have ray QP and ray QR are opposite rays. So QP and QR are opposite rays, so we know that this is a straight angle here. All right, so now let's go down and work on our problems. If the measure of angle PQT is 60, and the measure of PQS is 4x plus 14, then we need to find x. Well, if this whole thing is 60, then how much is this piece? We said that these are two equal parts, so if the whole thing is 60, then this piece has to be 30. So I know that PQS is also 30 degrees. And it's this one, so I'm going to set them equal to each other, 4x plus 14. Now I have an equation that I can solve. So I'm going to subtract 14. So I get 16 equals 4x. And then next I'm going to divide by 4 on both sides. and I end up with x equals 4. So my final answer, x equals 4. It said find the value of x. X is 4. Let's look at the next one. If the measure of PQS is 3x plus 13, and the measure of SQT is 6x minus 2, then we're going to try to find PQT, which is the whole thing. We know that these are equal to each other because they were bisected, so I'm going to set them equal to each other. So I've got 3x plus 13 equals 6x minus 2. And then I'm going to solve, so I'm going to get all of my variables on one side and all of my constants on the other. So subtract 3x, and I'm going to add 2, because I want to move my variables to the right, my constants to the left. 3x minus 3x, those are gone. 13 plus 2 is 15, equals. My minus 2 and plus 2, those go away. I have 6x minus 3x. I'm left with 3x. And then I'm going to divide by 3. So I get x equals 5. But they didn't ask me for x. They asked me to find the measure of PQT. So that means I'm going to plug x back into one of these. So I'm going to plug it into this one over here. 6 times 5 minus 2, I get 30 minus 2, so I have 28. Now that is SQT. That's only half of it. So I have to take that times 2, which will give me my PQT. So I actually have 56 equals PQT. So I'm just going to come over here and put the measure of angle PQT equals 56 degrees. Great. All right, let's try some more here. So I have another picture. I have ray BA and BC are opposite rays. I have BF bisects CBE, so that means these are congruent, so I'm going to go ahead and mark that. And BD bisects ABE, so I'm going to mark these. Now I have to mark them different from the other side because they didn't say they're congruent to each other, but they're just congruent. These are congruent and those are congruent. Okay? Alright, so then we come down here. If the measure of angle EBF, that's this one, is 6x plus 4, and CBF is this one, is 7x minus 2, then we're going to find EBC. That's just like what we did up here on this other one when we were working up here. So we know that these two are congruent to each other, so we're going to set them equal. So we have 6x plus 4 equals 7x minus 2. Again, moving our variables, so minus 6x. And adding 2. Those are gone from the left. I'm left with 6 equals. These are gone from the right. I'm left with an x. So x equals 6 there. But I need to know the big angle, so I'm going to plug it back in. So 7x minus 2. So I've got 7 times 6 minus 2. So this is 42 minus 2. We end up with 40 equals the measure of angle CBF. And I want the big angle, so times 2. So the measure of angle EBC equals 80 degrees, because it is twice as big as this. This is 40, this is 40, so the whole thing is 80. One more, and we are almost done here. If the measure of angle 1, and I don't even have a 1 marked on here, so let's get that fixed. Let's go, this is 1, 2, 3, 4. So the measure of angle 1 is 4x plus 10. The measure of angle 2 is 5x. We're going to find the measure of angle 2. So we know 1x and 2x are equal to each other, so let's set them equal again. So 4x plus 10 equals 5x. And then we're solving, so let's move this 4x. So that goes away. We're left with 10 equals x. But I want to know the measure of angle 2, so I'm going to plug it back in here. So 5 times 10. So this gives me 50. So the measure of angle 2 equals 50 degrees. And that's it. All right, we're going to work on this more in class. See you tomorrow.